Okay, this is open. Back to work, as I say. Okay, so we're all in. Okay, so this is another part of presentation, which is somehow a continuation from what we talked previously, focusing mostly on the human element and all its derivatives, so to say, human factor and human error. Okay, which is a very important, mostly safety parameter with regard to safety in shipping. Okay, frozen. It's not going down. No, I'm sorry. Okay, the maritime system, as we all know, is a people system. We can distinguish the presence of three interacting components: technology, environment, and the organization, and people are in the middle of this. There is an interaction of people with any part of this, with any of the other components, and this creates some inefficiencies in terms of delivering what is supposed to be the maritime systems service, whatever the case may apply. Okay, technology, when it comes to people, it is important to understand that we have a knowledge regime. Skills are important, abilities, memory, motivation, alertness are some of the aspects which are fundamental in the performance of people on board, but not only on board, also for people ashore. They do have to possess, to a certain degree, some of these attributes. With regard to technology and its relation to people, aspects which are very important is ergonomics. Okay, to be more precise, talking in terms of anthropometrics, equipment layout, information displays, the way information is conveyed to people, usually through displays, is very important. Maintenance, technology defines to a certain extent the maintainability of the systems with regard to days of how can an operator perform a maintenance task, reach strength and agility. Yeah, well, is very interacts with people's abilities, physical abilities, decision making. Yeah, safety and performance, and with regard to the environment, again there is interaction through temperature and noise, vibration, sea state, condition of the sea, regulations, economics, physical and mental performance. Yeah, it will affect that, fatigue, and it will affect risk taking as well. Sometimes the conditions of the environment are such that they impose pressure on taking actions or performing tasks which are a bit risky. With regard to organization, yeah, the organization has influence on people through exercising fatigue. It affects knowledge and the skills of people, work practices, teamwork, risk taking again. Under pressure coming from the organization, you're likely to perform tasks in a risky manner. Work schedules, yeah, they do affect how people behave. Crew complement, training, communication, and safety culture. Now, with regard to causes of shipping accidents, we all know that we can split it in two parts. One is to do with human causes and environmental causes with regard to mostly physical environment. The physical environment. A first split could be between 20 and 80%. This is true for other industries as well, something which we also detect to be true in shipping. Okay, 80% and 20%, let's not be too precise about these figures because it would be anything between 78 and 82 or even higher or even less, but this is the order of magnitude we're dealing with. And human causes can be allocated to operational causes, mostly to do with on-board tasks, mostly. We'll see later on what that means. By people working on board. Then we have something like 10% due to construction causes which are initiating shipping accidents and are embedded through the construction phase, and so another 10% through the design. As it was already mentioned earlier in the day, some problems could be associated with the design and some problems could be associated with the construction. So we can distinguish between the two, and again, this 80%, 10%, 10% is not an accurate, absolutely accurate division and allocation of causes, but we're talking in terms of the order of magnitude, and this is where we are with some deviation. Human element, human factor, and human error as just a typical example of some human error. There are numerous examples like that. Just thought this might have been appropriate, as been quite recent. Okay, human element, all the influences of marine safety and maritime system performances, everything, more or less, related to humans. Human factors are mainly related to capabilities and how humans fit within the organization systems and in relation to devices and equipment and all that. So it's got this ergonomic flavor about it, human factor. And finally, human and organizational error, okay, can define that as unacceptable or undesirable performance on the part of an individual, or if it's a group, then we're talking in terms of organizational error that can result in anticipated or undesirable effects. Now, with reference to human factors, there are various models which can describe how human factors can be best represented, and one of them is the so-called cell model. Where we have the operator in the middle, the red square, the capital L, and is surrounded by procedures, so-called software part of it, equipment, hardware part of it, sorry, the environment, and other people around him. So this is a pretty good description of what's happening with regard to human factors. And this is where it comes from. This is the source of the model. And in terms of the objectives of human factors, is to design systems that will enable people to use with efficiency and performance and minimize the risks of error. Okay, so is an effort to fit humans around the environment they operate in, whether that is the natural environment or the equipment or procedures, the management tools, and other people they have to cooperate and communicate with. So it's an effort of preparing the person, the operator, to adjust in an efficient manner with everything which surrounds him, but at the same time the surroundings have to be fitted also to the capabilities of the operator. So it's a two-way exercise. It's an interface. More or less we are trying to optimize the interface. We did mention before that human error in shipping constitutes something like 80%, but I have to look at this here, and we'll see that human error, whether it's on board, like crew error, deck officer error, engine error, pilot error, third person error, whether it's on board or ashore, constitutes something like 62%. Okay, so this compares very well with what we said before. I'm going to go back and just look at the 80% of the 80% here, which is more or less 64. It's 64. We did say neither the 80% of the human, neither the 80% of operation is precise, and so the 64 is not precise. And when it comes to information, from the UK, let's say UK P&I Club, that comes down to 62%. So human error 62%, most of it on board, the order of 45 plus 47 on board, and then we have some 80% pilot errors and 7% short person error, and then we have equipment failures, mechanical failures, structural failures, and other. And when it comes to other, probably it could include what we previously commented, like being the environment, the 20%. Could be acts of God and things beyond our control. Okay. So the dominance of human error is evident. That's why it's such an important issue. In shipping, we need to address it in order to reduce risks and reduce accidents. Now, Homer, apart from having a Greek name, Homer Simpson, yes? Okay. Embodies several working class stereotypes. He's crude, bold, overweight, competent, clumsy, lazy, heavy drinker, and ignorant. Okay, he's a stereotype. Not everybody's like him. And not every working class person is not like him, but there are a few like him, so that's the important thing. But he says, but he's essentially a decent man. And if you look at Wikipedia, this is what you will get about Homer Simpson. Anyway, all right, so we have to live with him, and we have to see how he adapts to the whole system. Now, we can look at human influences in marine accidents, and in this case I picked up the Prestige accident off the coast of Galicia in Spain, a very known accident for the European region with a lot of policy implications. Okay, so we can divide human influences coming from the level of organization, level of supervision, some background conditions for creating the right environment for performing finally some unsafe acts. All these levels, they do have some inefficiencies. They have weak points. We expect any level and any system to have some weaknesses, and this is how we represent them. Of course, we expect them to be increasing in number as we go down this trend of system representation, and without really assessing which is the most important weaknesses and the lesser important weaknesses, let's assume that they're all important, but at the same time recognize that, as we do usually say, the problems start from the top, and they do start from the top, as always, and we recognize there are some organizational problems, probably very important, which are reflected further down the line. So we're talking in terms of failed or absent defenses. I called them weaknesses before. Okay, that might be the case. And then what we get is a chain of events which will lead to an accident like what I just said, the Prestige or any other accident. Now we can recognize that some of these failures, when it comes to human failures, can be classified as being active. Okay, something which is regarded, which is assigned to acting and unsafe acting, of course, is an active failure. It's like performing a task in an unsafe manner, but in order to do that, there are some other failures which are contributory to the final act, and we talked recognize we recognize them as being latent or hidden failure, because they're at an organizational level or a level of supervision or some preconditions for unsafe acts, and this is what we have to address. And this is based on a model of reason, very known, famous model called the Swiss cheese model. Very good. It looks like Edam cheese has holes, yes. So this leads us to, is related to the human factor analysis and classification system, where we can split organizational influences in the resource management, in organizational climate, in the organizational processes. Then we have the unsafe supervision, which which can be subdivided into inadequate supervision, chief superintendent, engineer or officer be exercising a supervision which is not adequate in a shipping company. Planning of inappropriate operations, yes, we plan some operations which are inappropriate. At this level, if there is a problem, it should be corrected, then it's not corrected. That can be a problem, that can be a reason. And sometimes deliberate, let's say, non-conformance with what is expected, either through regulations or through laws or norms. In any case, we have supervisory violation. That could be a reason which leads to an unsafe supervision. Now, with regard to preconditions for unsafe acts, we can detect the presence of mental states which are not favorable. They are adverse mental states, adverse physiological states, yeah, for the operator. Physical, mental limitations, very important. Everything is important, but I'm just saying that a lot of the design of a lot of systems is not really aligned with the physical and mental capabilities of operators. That is an ergonomic issue here, as we mentioned before. Crew resource management, yeah, not too many people available, not the right people available, that's a problem. And there's a question of awareness or readiness of a person to perform what he is supposed to. Unsafe acts, when it comes to the final stage, where everything really, which is the last barrier before something happens, or is the last, let's say, cause for leading to an accident, we do this through decision errors. So this is at the level of the operator. A lot of unsafe acts are performed on board, some of them at office. You can do a decision error at office, and that can affect something, can lead to a shipping accident, given some instruction from the office which is not correct. Skill-based errors, yeah, that's mostly to do with an operator, the way we work, operate machines, equipment, and all that. That's relevant to skills. Perpetual errors, yeah, this is more or less some repeated errors. We do these things all the time the same way. Routine violations, exceptional violations. Okay, so this last one, which is presented through the red rectangles, are really they're not true errors as such, because there is some intent in doing something not the right way. So, but we still distinguish them between routine violations, something we do all the time, and something wrong which we do at an exceptional rate. In other words, rarely, not very high, but sometimes that happens too. Now back to the organizational and influences and resource management, organizational climate and organizational process, human resources, selection, manning, training. Resource is to do with humans, is to do with money, has to do with material resources. Yes, that's true as well. And then moving to the organizational climate, is very important how the company is organized, whether there is a hierarchy, what they call chain of command. Delegation of authority, yes, that's very important. Somebody high up cannot do everything. He has to pass some authority to some people under him in order to perform some tasks, well, some decisions, not necessarily just manual tasks. Communications are important. Accountability, yes, very important. Policies are involved in the organization. How do you employ people? How you send them home, fire them? Promotion, drugs, alcohol, and general culture of the organization, very important, because that will decide how do we go about exhibiting and demonstrating and applying respect to norms, regulations, standard procedures, and all that. And very important, what are values, what is the, let's say, the prime objectives of our organization, what we believe in. Okay, organizational justice. Okay, to be fair, yeah, an organization has to be fair in the way it treats its employees, more or less. Operations, yeah, how fast? Under time pressure, yeah, that's very important. Production, sometimes we ask too much, well, to do too many things in a very short period of time, that's a problem. Incentives, you have to provide the appropriate incentives in order to get performance appraisal. Yeah, there has to be some assessment procedures in what you do. Schedules, deficient planning is a problem, yeah. And procedures, as I said before, standards, clear objectives, documentation, instructions, oversight. Looking ahead of things with regard to risk management, as already mentioned, is very important. Having the right safety programs, being proactive, problems which may arise. Now, with regard to unsafe supervision, again, we can give some examples: failure to provide guidance, some clear instructions about how to operate things, again, oversight, training, and fail to tackle, to track, not to tag, sorry, qualifications, track, performance, fail to provide correct data. When it comes to planning operations, you need the data, correct data, time, tell him what to do. Okay, as part of proper supervision. Improper manning, is a problem. Or planning tasks which are not according to rules and regulations, and provide inadequate crew rest. That's a big problem in many areas, and shipping is one of them too. Okay, failure to correct the problem. We have some typical examples, such as not providing the remedial, let's say, action necessary. That's what it boils down to if I say failure to correct the problem. And supervisory violations, unnecessary hazard. Yes, we let the green light, give the green light to embark on something which creates an unnecessary hazard. That's a problem. Or we involve unqualified crew to perform a task. Again, failure to enforce rules and regulations. Okay, with regard to the preconditions for every different case, such as we have to see what involves, such as a cause as an adverse mental state, would be very channel attention. Where somebody is very concentrated on something, he doesn't see what's going on around him. That's a problem. You should be concentrating on what you're doing, but you can't be completely touched. Sometimes important things take place around you. Complacency, okay, so sometimes you're too relaxed about what you're supposed to do, and that's a problem too. Distraction, okay, I did say before that we have to be aware of where we are and what we're doing and where we are in relation to our surroundings. Sometimes that can give you a distraction, so everything has to be somehow balanced, optimized. Mental fatigue, okay, too much mental work, that will create a problem with a mental state we're in. Nostos, okay, for Greek that means homesickness, but some people might know that's what it means. Haste, things you have to do very fast. As I said before, situational unawareness, okay, you are in a situation where you're not really making a very good assessment of where you are. That's a problem. Motivation could be granted to something else. You're not motivated by what you're doing, or you probably what you are supposed to be doing, you're just fed up with it. So you end up with having what we call task saturation. Similar examples with regard to physiological states. Physical and mental limitations, yes. Sometimes because of human limitations, we haven't got enough time to react to something which is happening. That's okay. That's an issue which we have to look at or take into account. Visual limitation, yeah, that's compatible intelligence or aptitude. Okay, something we're not capable of dealing with that, either because we haven't got what is required in terms of knowledge, skills, but in this case, references make to how clever we are, or what is our attitude. Okay. Physical capability. Now, crew resource management. Fail to back up, communicate, coordinate, contact adequate brief. Okay, is a lot of do with how we manage our human resources, in this case the crew, and it is important to cater for the existence of backups in case somebody can't do the job, fails to do so. We have some alternative option available to another person. And personal readiness with relevance to excessive physical training, yes. Self-medicating, that's violation of crew rest, violation of bottle to throttle requirement. A lot of this, okay, classification and some of these examples, although there has been some adaptation of the shipping industry, they do come from the aviation industry. So some terms might be relevant to that. Okay, so bottle to throttle, it could be something relevant to that, but it says explicitly, it's too close, mixing up our priorities there. In other words, like drink and drive problem. Unsafe acts. So this is what we're mostly looking at the level of shipboard operation, although some of these errors can be found also at the office ashore, but most of them are related to shipboard errors. Decision errors, okay, skill-based errors, with some typical examples. Of course, you do need some knowledge and expertise in order to be able to utilize the so-called navigational aids, controls. Well, that's a problem. You haven't got the appropriate skills to do that. Can easily omit steps in procedures, and that's a problem as well. Perceptual errors. Not perpetual, perceptual, sorry, yes. Perceptual errors, errors which are associated with the way I see things, okay, so this is a problem as well. It involves, in many instances, people of the bridge. Okay, so we might have so-called mirages, as I call them, some illusion. We're looking at something we think is further away than what is in reality, and that can give us a problem. Okay, misjudged distance and speed is a typical problem. Failure to adhere to brief, routine violation. We know we have to do something, in a certain manner, but we routinely do not do that, and that's a problem. The same applies to the exceptional cycle. Okay, so the finding of human error should be the starting point of an investigation and not its conclusion. Yeah, okay, because we have the conclusion is too late. Human error, another type of classification, takes us to skill-based, rule-based, knowledge-based errors, and this is according to Rasmussen, very important researcher on this issue. So we can split unsafe acts between intended actions, usually violations, and unintended actions, which could be basic error types like sleep, lapse, mistake. Okay. And reason is another researcher who is approaching the modeling of human errors in this manner. Managing human errors, 1, 2, 3. Okay, we found something. In the previous lecture, we talked about the fault tree analysis. Okay, we find there is a spot there, there's a cause, and it could be the human presence, which has a very high probability of occurrence. It's very unreliable as a component in the system, and you say, okay, you are to fail, I'll kick you out of the system, and I'll take the prize. Number 4, because he discovered which was the weakest link, in this case the human being or the operator, he gets a prize for it. That's not the way we go about managing human error. Skill-based errors are mainly treated through ergonomic improvements. Rule-based errors, we need more training and procedures, and the safety and the same more or less goes for knowledge-based errors. Yes, training, safety management system, that's important as well. Training is very important. Now, when it comes to violation, because that's something deliberately implemented, we have an intent to break law, break a regulation for some reason. How do we cure it? Okay, depends. Depends what the motivation is behind doing a violation. Okay. Now, some design errors, you can see here we have problems. Okay, that's anthropometrics, ergonomic problem. We've got this valve up there, nobody can reach, or a fire extinguishing point, and this is usually covered by another door there or something. So you haven't got any accessibility in it. This is some of the usual problems, bad design. Now, some routine violations: keep door closed and the door never closes. We keep it open, and this is a problem. Or we dealing with some task on the deck and we're not wearing, I see they're wearing protective lenses, but they're not wearing protective helmets. At least one of them doesn't. That's a problem. Why? Because we can't be bothered. That's a routine violation. Yeah, because we always done it this way and there's no point to do what we are supposed to do. Exceptional. Okay, this is a problem. Okay, so we do a lot of things on ships, take risks without, not very often, but exceptionally we do those as well. Well, sometimes they argue, or are they routine? Who knows? It doesn't happen every day, but that's what happens sometimes. Now, with regard to hazards, we said, the hazards are conditions which have the potential to create accidents. And with regard to human-related hazards, we recognize that on a personal level, we're talking in terms of reduced ability, reduced vision here, lack of motivation, as we said before, lack of ability, fatigue, stress, at organization and leadership, yes, inadequate vessel management, inadequate supervision, lack of coordination, lack of leadership, that's important, yes. When it comes to management, company management at a very high gain level of organization, we might have inadequate routines and procedures. And this is where inadequate manning can be also a problem. As I said, know a lot of people involved of what is the requirement of the task, and probably not the right people. Some of them untrained. That's a problem. Inadequate routines, yeah, with regard to navigation, engine rooms, and all that. Task features, yes, some of them are very complex, and some of them are painful. I mean, too much to do for any operator, and that's a problem. Or there are people who are unfamiliar with the task, and that is an issue. The task objective is not very clear. Somebody is doing something and he doesn't really know why he's doing it. That is not something which works as a driver for doing the job properly. But you better appreciate what you're doing, in other words, even if it's a additional task for a purpose for it. You should know what it's all about. You might be asked to do too many things at the same time, different tasks competing for attention, that's a problem. And then working conditions on board, this is, seen this before, we have to look at the noise levels, vibration. Okay, sea motion is something which is beyond our control most of the times. Some ships, okay, if you allow for the benefits which can stabilizers offer you and all that, but that is not the case for every type of ship. Usually we do it for the passengers, we don't do it for the crew. So it involves passenger ships mostly, but there are other issues as well which can create physical stress, the presence of toxic substances, temperature, environmental, and night watches as well. They can physically strain you. Okay, and in terms of what we use and what conditions we use it, issues of light, buttons, or as we say, inadequate illumination is a problem. Poorly designed human-machine interface, that's very important, we know that. If that design is not very good, we expect to have problems. The social climate, inadequate communication, lack of cooperation, background conditions, restricted visibility, high traffic density, restricted water. Okay. There is some issue with regard to communication, which is very important for shipping. Several issues here, apart from the apparent language of communication. That is one issue, but and everybody understands each other. That's very important when you are on board. But with regard to the quality of communication, it is important also to note the influence of what is called the power to distance ratio. In other words, the hierarchy on board how does that facilitate communications? A lot of experience comes on this issue gained from the airline industry, where we do detect, for example, that certain nationalities communicate much better, more effectively than others. Okay, so what I'm trying to say is when you have a pilot on an aeroplane and a co-pilot, for example, of Greek nationality, their communication quality is influenced by the hierarchy, is governed by the hierarchy between them much more than some other nationalities, and this definitely has an effect on how we communicate at moments of crisis. In other words, okay, the final decision is on the master of the ship, no doubt about that. But and he has to take responsibility. But before he arrives to that, if there is any time to make a decision, it is important to know whether he communicated and he discussed the problem he's facing with somebody around him, and how he judged their opinion, whether he was too authoritative or he made allowance for another solution. Of course, finally, it's up to him to decide, but it's very important to look at this issue as well, which the airline industry has touched upon more than 35 years ago. That's important. Well, now there are a lot of hazards which can be presented to the crew ship, mostly coming from various operations or things that are carried upon the ship, and the vessel is subject to a lot of hazards, as we know it, either internal or external influences such as explosion fires and or storms, some underwater obstacle ahead, have a collision, contact. Okay, so additional hazards, substances which we have on board, and they might affect not only just the risk involved in the ship under operation, but also influence how we perform as a result of some undesirable effects. So we're going away from human factors and human errors, but we see a list of the threats which might be faced with, and causes which might lead to undesirable events throughout the ship. The cargo itself, might be flammable, might be toxic, the weight of it, density of it, whether it's corrosive, that's very important. We have also other hazards are linked with the operation itself, either of the personnel or like the crew, the way they use the tools or the electrical equipment, or the also hazards which might arise from the ship itself and the cargo it carries, like pollution or being in enclosed spaces, etc. Okay, thank you very much. This is the last page of the presentation. Hope covered this the best we could. Actually, there's a lot of things we can say available for any question. Thank you.